Hi, Piotr speaking here on Quasar Training part 15, and in this part we're gonna have a look at going asynchronous with methods and source variables. And let me first explain the term. What is synchronous, what is asynchronous, in Quasar terms, that is. So this all relates to delegates. Delegates are those methods that you or we've been trying to write in device logic classes. So you remember we've been writing a delegate for writing, delegate for reading. In the previous part, I think in the parts about method, we wrote a delegate for calling things. So when you want to handle a method call. And so whether we're talking about synchronous and asynchronous, it's about whether the delegate is executed directly from the protocol stack network thread or threads, that depending on the protocol stack, or independently from it. So we have two possibilities. So synchronous, of course, means directly from the protocol stack, which means the protocol stack via Quasar will route this call to the delegates that you will or you would write normally. And then the story here actually starts with the question: what happens when your function, when your method, when the code that you wrote is blocking? It takes time, it's potentially blocking. What happens then? And I will demonstrate this in a few moments, what happens then. But a general answer is it's not a desired situation, because by writing blocking code, you will simply block the network thread of the protocol stack, which means you will impact processing of OPC-UA requests and replies and the behavior of your Quasar-based server in general. So this is something to be avoided. Then, on contrary, we have an option called asynchronous, and when the delegate is invoked, it's invoked in a context of a separate job, and the separate job is running in the contents of so-called Quasar thread pool, which has its own threads, which means that the root of invocation is the client. Client sends a request, which would translate into a delegate, but it's actually a job which is created, which is added to the thread pool, and the thread pool has some resources like threads and a list of pending jobs that it can take and process one by one, never exceeding the maximum number of threads, but at the same time liberating the calling threads to continue doing its own job. And then when the job is finished, it can notify the network thread that there is a reply to be sent back to the client. And in this fashion, you can write a completely safe, in the sense of being blocked, completely safe longish methods, functions, blocking, potential blocking, anything like that. Which of course doesn't mean you should, do this everywhere. You could argue that I want to go asynchronous everywhere. I don't think it's a good approach, because it in the end costs some resources. So I would say make sure is your function blocking or it's not blocking. And if it's blocking, just go asynchronous. So this applies to, as I told you, all three things. So like write delegates from source variables, read delegates from source variables, and call delegates from methods. And of course, there's absolutely no relation to cache variables. So cache variables are never related to this, and cache variables are kind of always synchronous. And by the way, as a rule of thumb, you should never, absolutely never, ever put a blocking call in a cache variable delegate. So before I go to the demo, just to mention that the thread pool, which I remark, is configurable by the Quasar config file, and the default, if you don't put those arguments, is the max pending number of jobs to do is 1000, and then there is a minimum and maximum number of threads for performing the jobs at any time, which is between 1 and 10, and I hope I don't forget to show this to you in the demo. And one more message, this exercise can be only done with UA SDK, so if you want to obtain the evaluation version, you can learn how to do that in part 13, and if your company has a license, or if you have a license for UA SDK, then of course in part 13 you can also see how to how to profit from the license. So one more point of attention here. As you see, I've opened 2 instances of Unified Automation UA Expert, because I will use one of the instances to actually invoke an action, invoke the delegate, and in the other, I plan to show you how the server is affected. But of course, the same situation will happen with any client, whether it's WinCC UA or UA objects or any Python-based client or whatever else, you will see the same behavior. Or at least I expect you would see. So, let's now focus on what we are talking about. So, let's start with methods. It's slightly easier, I think. So you remember we added this turn on method once in the chapter about methods, and then we wrote some code. Wait, just to clean this a bit. So we wrote some code. You remember there was like call turn on, and there was a method called turn on that you could invoke, of course, and this would like send a command to the motor, right? So so now let's assume, or let's simulate that the actual act of sending the command takes time. It's, if, for instance, you pass this command over another API or over HTTP or some SOAP or whatever that is, and you actually wait the reply in a waiting mode. Okay, so let's try to simulate this. So instead of sending the actual command, I would actually simulate that I'm taking quite some time for this. Let's say the worst case scenario, like 30 seconds. Yeah, I know I should go here with standard, with boost, cron or whatever, but it's really just for demonstration purpose. So here I wait like 30 seconds. And before this happens, I would actually like to change the order. It would be just slightly easier to see things if we first set rotational speed set point as per method call. Okay, so this I've done, and the point of attention is that this method, as per the chapter on methods, stays synchronous. Okay, so means that this particular method called turn on will be called in the context of the network thread of the protocol stack. So I'm about to build my server. Okay, perfect, and then I run my server. Okay, and then look, so is it connecting? I think it should be connecting, right? Okay, perfect. So I have controller and motor, and then I have my method called turn on, and then I will use another client, so the client on the right, to actually keep watching at the processing of my server, right? And I will clean the log file. Sorry, not the file, just the log pane. So you see what I can do in addition, it will be even more convincing, I think, is when I take the settings of the subscription and I switch to data change filter, including timestamp, and that means that absolutely every update will be sent as a notification event. So you see that the server is processing something, and in fact I get all updates even though the value doesn't change, but I now I get all updates, right? So I see there is really some traffic. Okay, now so I'm now about to call turn on, and doesn't really matter what speed is this, but I'm about to do that, and I'll see is there any effect on the server. So let's call, and clearly I already see that this is being processed, as you see. Yeah, so you see it's still taking time to call this method. Now I actually see it's even funnier because the application kind of got stuck. But see what happened here. So this is your independent, another client that could be your control system or WinCC UA, doesn't really matter. But look, something clearly bad happened. We got into warning, watchdog timeout, and error API reconnect, and then, okay, only after some time, the data is available again, which clearly indicates that server got into trouble processing things. And it is not particularly shocking because, well, that function was called in the context of network processing thread, request processing thread, and voila, it happened what had to happen, which means it simply got blocked. And this you should always avoid at all possible costs. This is not a an acceptable situation. You never ever do that. Remember. So, how you can get away from this situation? Well, if you know you have a delegate which is gonna take time, instead of synchronous, you choose asynchronous. So what then happens is there is a call like we had. There's a call coming from UA expert or another client, and it's being executed in the context of a separate job in a Quasar thread pool. So let's give it a try. Okay, so our server is built now, and let's try to run it. Nothing, I think, particularly shocking that it starts like it was. Also, you know, probably noticed, but I'd like to pay attention that we did not have to change anything in our custom written code to actually profit from asynchronous call. It's you know, part of magic that Quasar does for you, that you can profit from that. Okay, so as you can see, I'm here watching my updates, and then I do turn on, and let's see what happens. So, whatever. Of course, this client is still blocked. This is not very shocking, but look what happens here. The server keeps processing, and there is absolutely no indication of any problem. So it simply means that this client, even though this client is entirely blocked, this client keeps processing. There is absolutely no problem with that. So, of course, at some point of time, this will finish its call about 30 seconds afterwards, because we simulated it to be like 30 seconds. Voila. So now this is unblocked, but it was actually not a problem at all, because this guy kept processing all the time. So, the same situation. So that was for the method calls, but actually the very same situation is the case for source variables. So you remember we added this class which was like source variable example. It was not really related to our motors or something, but then we added a source variable, we set the data type name, and then there was address space read and address space write, and we put synchronous and forbidden. So which means that if in our device logic of this class called source variable example, we had a potentially blocking call, then the same situation will happen, and then the way to fix this is asynchronous. Okay, which I will not show. I mean, you can consider this a homework to be done. You can really try, and this is what will happen. Now, the last thing before I forget is that I remarked to you that the settings of the Quasar thread pool is configurable, and where to find this. So when I'm playing with Eclipse, of course, my configuration schema knows that we can find this. So standard metadata, okay? Standard metadata is something defined by Quasar itself, okay? So then I do add child, and I have few options, and then I find source variable thread pool. And now it might be slightly confusing because it mentions about source variable thread pool, but this is actually, you know, it comes from the time when this thread pool was only used for source variables, and this is no longer the situation. Now it's used by many more things. So for your information, when you do that, minimum number of threads is 1, and this is 10, and this should be 1000. Okay, maximum jobs is 1000. But of course, well, those are the default settings. So if you want to keep the defaults, you don't really have to add this element, because either way it's like that. But everything depends on the workload of things and how things distribute in time. If you have like many jobs appearing at a very single moment, and then it simply takes time for them to process, you might be interested in just in that number. And especially if, you know, if they kind of restricted or touching the same resource. On the other hand, when the number of resources is very big and they can work independently, then and you have many CPUs, then of course you can go easily with maximum number of threads. So it's a generally rich topic, which I don't think this part is really proper to study, but at least I showed you how to configure the settings of the source variable thread pool, or Quasar thread pool, in fact. Okay, so the takeaway here, which I'd like that you keep with you after this part of the training, is that you have delegates which are either running in synchronous context or asynchronous context, and that it's a serious danger or serious threat if you take them to be synchronous, but then they might be potentially blocking, because this means you'll produce a misbehaving software product, and if you know something it can be blocking, then of course you go asynchronous. But of course you don't put everything asynchronous because it costs much more resources and it doesn't really make sense. Okay, that was it. Thanks for your attention and see you in the next part.